In the previous video, I briefly explained how you can calculate the maximum height of a cannonball. Now it's your turn to have a go. So now we're on the moon. We're going to shoot a cannonball vertically upwards at 50 meters per second. Gravity on the moon is 1.622 meters per second squared. Calculate the maximum height of this cannonball. Okay, but before you do it, let me just quickly give you an example. So here we're still shooting the cannonball at 50 meters per second, but on gravity, on Jupiter, the gravity is 23.12. Gravity is just a ball of gas, so you have to imagine that we've got a platform to rest our cannon on. So just imagine there's something for us to rest our cannon on. So in order to find out the maximum height here, inside your mind, visualize the three graphs. Okay, you've got your acceleration time, you've got your velocity time, you've got your distance time. Visualize this one inside your mind. So we're going to play about with the velocity time graph. This is the most useful of the three. So to find out the maximum height, sketch this sketch the velocity time graph. Now initially, when time equals 0, the velocity is 50, so we know this would be the 50 mark. Okay, and then when it gets to the maximum height, don't forget there's gravity is always acting downwards here. So we can draw our graph like this. Come up with the equation for this line here. Now this line you can imagine as y equals, it's a straight line, so it's going to be y equals mx plus c. Now it's a negative gradient, so the acceleration is negative. Now what is the acceleration? Well, the acceleration is actually this. The gradient is actually this, but because it's downhill, we're going to stick a negative in front of it. So the equation for this straight line would be y equals negative 23.12x plus c. Well, c in this case is 50. Okay, so the equation for this line here, now substitute this here and the t into the x. So the equation for this line is v equals I'm just going to switch these two around so it looks neater. 50 minus 23.12x. Now this is the equation for this straight line here. Okay. Let me just quickly tidy this up. So when you start with the problem like this, just quickly sketch the velocity time graph, and it should look something like this. This is 50 here, because the initial velocity is 50. This is the time that we're interested in. This is the point when the velocity is 0. So the cannonball is going to travel up like this, and then at the maximum height, the velocity will be 0, and then it starts to fall back down again. So that's why the velocity over here is negative, because it's going downwards. Well, anyway, the first thing you do, come up with the equation for this line, and it was it was v equals 50 minus 23.12 t. Yeah. So this is our equation now. Now remember, when you've got the velocity time graph, the area underneath that represents the distance traveled. So here, when all the way up here, the velocity here at this point here will be 0. Now you want to find out the area underneath the graph. Now the area underneath this graph here represents the distance traveled, meaning is a maximum height. This is what you're trying to find out. So you're trying to find out the area of this graph. Well, you're interested in the time here, the time at this point here. What is the time when the velocity is 0? Now use this equation here. Put 0 into the v. So 0 equals t. Equals this 50 minus 23.12 t. Okay, because you're trying to find out the time at which the velocity is 0, which is this point here. Once you've got this time here, this distance here, you can use the height here times the width here, but you need to know the time first. So put 0 into this v here, because for you to find out what time this is here, well, the velocity at this point here will be 0, because look, velocity is decreasing each time, and at this point here it will be 0. So put 0 into the v to find out the time. So now we've just put 0 into the v. Now try and find t here. Okay, so add this thing to both sides. So it will be 23.12 t equals 50. Now divide both sides by oh, sorry, hang on, bear with me. Divide both sides by what, at the moment you've got this bubble here multiplying with this bubble here. So divide both sides by 23.12. So this will be t equals 50 divided by 23.12. So jump to a calculator. 50 divided by 23.12 equals 2. Let's just say 2.2. Okay, 2.2. So is a time. So it's in seconds. So t equals this. So at this point here, t equals 2.2. So now we know the width here. So just get 50 times this thing here and then divided by 2. So the distance traveled, well, the area here equals let's just say area equals the height here, which is 50 times the across here, which is 2.2, and then divided by 2. So that equals, hang on, calculator, times 50 here equals that, and then divided by 2 equals 54. Okay, so roughly 54 meters. Well, area here, well, remember area is also maximum height. Maximum height. So maximum height equals 54 meters. So remember when we did this on Earth, the maximum height was 125 meters. Now on Jupiter, it's what was it? What was that earlier? Oh, it was whatever it was. Okay. Now you're going to do it on the moon. So the trick is to immediately jump to the velocity time graph. Okay. Well, once you're given this problem here, jump to the velocity time graph, and then well, come up with the equation for this straight line, and you're trying to find out the time at which the velocity is 0, meaning the time at which the cannonball is right at its peak. So find out the time. So that time represents this width here, and then all you have to do is find out the area of this triangle. Well, anyway, it's your turn to do it now. Press pause and have a go. Okay, so yeah, press pause and have a go. Sorry. Okay, so to do this here, immediately jump to the velocity time graph. And then the velocity time graph will look like this. The initial speed, the initial velocity is 50. Okay, and then we'll come up with the equation for this line here. Well, every second there's a deceleration of, well, an acceleration, a negative acceleration of minus 1.622. So the equation of this line will be, well, it's a straight line, so start with y equals mx plus c. Okay, now you can see that the line has a negative gradient. In this case, it's negative 1.622 x plus c. Now c is the intercept. The intercept here is 50. So let's put 50 into there. Minus 1.622 x plus 50. Okay. So now just change the y and the x around, because we're talking about velocity and time. Y and x is really good for maths. Anyway, so switch the so the velocity equals now equals negative 1.622 t plus 50. Okay, now tidy this up. So velocity equals 50. Just switch a 50 around. So it just looks neater. That's all. Okay. So now we've got our equation for this line here. This is our equation, but we are interested in this time here. Well, at this point here, the velocity, the up and down is 0. The velocity is 0 at this point here. So put 0 into the v. So 0 into the v and try and find out the time. So 1.622 t. Now add this thing to both sides. Okay. So that would be 1.622 t equals 50. Now divide both sides by this thing here. So t equals 50 over 1.622. So now jump to a calculator, punch it in. 50 divided by 1.622 equals. Let's just round it off to 30.8. 30.8 t, so seconds. So when you shoot the cannonball up, it would take 30.8 seconds to well, for the cannonball to reach the velocity of 0. Well, it takes 30.8 seconds for the cannonball to come to rest here. Okay, and then it will start to fall down. Well, anyway, so this point here is 30.8. Now you want to find out the area underneath this graph here, this line here. So get the height, which is 50, times this thing here. So maximum height equals 50 times the distance here, which, well, the time here, 30.8, and then because it's half of a rectangle, divided by 2. So jump to a calculator. Where is it? So here is 50 times 30.8 equals this, divided by 2. Equals this, 770 meters. 770 meters. So a cannonball like this, 770. Remember that. So a cannonball like this on Earth is 125 meters maximum height. On Jupiter, I can't remember what. You have to scroll back to look it up. The maximum height on the moon, it would be 770 meters. So you see, when the gravity is weak, that means the acceleration downwards is much smaller. So on the moon, it's able to travel really high up. Whereas on Jupiter, it's a lot stronger. The gravity is a lot stronger, so it can't go as high up. Okay.